Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 3066, minimum operation to exceed threshold value 2. Let's have a look on the problem statement. What is given to us? An integer array and another integer k. As you can also see in the parameters of this function, nums array is given to us and k value is given to us. And we have to perform some kind of operation. And what is that operation? Take the two smallest integer x and y. Remove xy from nums and then add minimum of x into y, double that value plus maximum value anywhere in the array. This is the operation that we have to perform. And there is a note that you can only apply the described operation if nums contain at least two elements. If there is no two element, then how do we get x and y? Okay, so from this nums array we have to get two elements x and y, and after that we have to remove x and remove y and then add minimum of x comma y into 2 plus maximum of x comma y, maximum value plus double of minimum. This item we have to add in the array. Okay, let's have a look on the constraints as well. In the constraints they are saying that the value will go till 10 power 9. Till 10 power 9, so we might also have to take care of the overflows situations. And the value of k is also positive, element value is also positive, and this is the length of the array going till 10 power 5. That is fine. Okay, so in this case, if I just have a look on the example, first example is 2, 11, 10, 1, 3. And what is the value of k? K is 10. If I just make a dry run on this example, let me take the values of this example here. First operation. In the first operation, what are those two elements I'm going to get? Two minimum elements are 1 and 2. Just take 1 and take 2. And what item I have to add? Minimum of 1 comma 2 into 2 plus maximum value. Maximum value is 2. Minimum value is 1. That is 2 plus 2, which is 4. 4 I have to insert in this. So this is our operation 1. Operation plus plus. Operation is 1. Now in the next operation, see, my destination, my aim is that all the elements in the array are having value at least 10. So in the next operation, if I just take 3 and 4, so what is the minimum value? Minimum value is 3 and the maximum value is 4. This is the expression 3 into 2, 6 plus 4, which is 10. I'm removing it and I'm inserting 10. And the operation will be updated from 1 to 2. Now in this case, if I see all the items in the nums are greater than equal to k, return the minimum number of operation needed so that all the elements in the array are greater than equal to k. This is something we have to achieve. We have achieved this condition and minimum number of operation are 2. If you are making one more operation, you will also get all the elements greater than k. But minimum operation is 2. So 2 is going to be my answer. Let's have a look in this. 2 is the answer. Okay, so here problem statement is clear to us. Now we just have to look for the approach, think of the approach and think of the best data structure which is suited for this problem. What is the best data structure suited for this problem? See, every time we have to know the minimum element and x and y. What are those x and y? X and y are the two smallest element from x and y from nums. Two smallest element. From this nums array, every time I have to get two smallest element. It means I need to get minimum element quite frequently. And after that I'm inserting something. Again I'm getting two minimum element. And until what situation I'm adding those elements, till the minimum element in the nums is greater than equal to num. See, again in this case, our terminating case is also something like minimum element should be greater than equal to k. What I'm saying is, when should we have to stop applying operations? Minimum element of nums is greater than equal to k. If minimum element is greater than equal to k, it means all the elements are fulfilling our condition. Our condition is greater than equal to k. So for this case, the heap data structure would be best suited for our need. And in the heap data structure, if I just consider Java language, there's a priority queue implementation for heap, which is the default implementation of min heap. And in this case, we definitely require min heap. See why we are requiring min heap? Because in the min heap, getting the minimum element is going to be done in order of one time. But in this case, we require two minimum element. So first minimum element will be in order of one time. Second minimum element is order of log n time, because one heapify operation will be taking place between those two, x and y. And insertion element is also going to take log n time. So let's try to write code this approach. Here we have decided that we are definitely going to use priority queue. Priority queue of, let's take integer. Later on we will see whether we are not getting any overflow situation. Priority queue is equal to new priority queue. Our min heap is ready. Now we just require an answer variable which is going to store our operations, and that is going to be my return type from the function. Now we have to keep applying operation. Okay, while loop, keep applying operation until what? There are at least two elements in the array. Okay, two elements in the array. See, we are not dealing with the array anymore, because insertion is array, taking elements in array or every time getting minimum element is a very costly operation. So let's add all the elements from array to this priority queue. For each loop, integer, and for nums, priority queue offer. There are two operations for every queue type data structure, offer and poll. So offering means I'm adding into the priority queue, adding an element in the priority queue. Now priority queue will be our new array. So here priority queue dot size should be greater than 1. It means at least 2. And apart from that, all the element in the priority queue should be greater than equal to k. Greater than equal to k means I have to stop applying operation, but I have to keep applying operation if it is less than k. Priority queue dot peak element means minimum element is less than k. If minimum element is less than k, so we have to apply the operation. If minimum element is greater than equal to k, no need to apply operation. So in this case, we will do something, and after that I will just increment my answer. It means increment operation plus plus. Now do something. Do what? Get the value of x, get the value of y. What is x? X and y are the two minimum elements. Priority queue dot poll, and this is priority queue dot poll. Got two elements, and then I have to add some value in the array. What I have to add? The expression, as you can see in the problem statement, minimum of x, y into 2 and this. So pq dot offer math dot minimum of x comma y into 2, double the minimum and take the maximum, x comma y. Okay, two element I have taken and I have offered the element, and this is our operation incrementing the operation counter. And now I can test over sample test cases. On the sample test cases it is working fine, but if I submit it, let me see if it is passing all the test cases. No, it's not passing all the test cases. Why? Because there might be the situation of overflow, as our nums value is going till 10 to the power 9. So in this case, what I have to do is, here I am taking x into y into 2, multiplication with 2. So here this value might cross the range of integer. So instead of integer, take a long type priority queue. If it is long, then this value should also be long. And if I'm getting some value out of priority queue, that should also be long. Then run it again. This case was failing in our previous approach. So let me run it again. This time it is passed because there is no overflow and we are getting the right answer. Now I'm submitting the problem. It got submitted successfully. I hope you understood the approach. Thank you guys. Bye bye. Now let's discuss the time complexity of this approach. What is going to be the time complexity? We are taking a priority queue and inserting the priority queue. That is an order of log n time operation, or this is also order of log n time operation. So overall, if the nums array size is n, our time complexity will be n log n time. What about space? Space, you already know that space is n because we are inserting every element in my priority queue at line number 5. So this is the time and space complexity of our approach. Thank you guys. Bye bye.